This video is going to review exponents and how they work. First, I've got the reminder of three properties. Notice for the first two, the bases have to be the same for this to work. For these, they're x's. They could both be y's or could both be 3's or anything, but they have to be the same bases. When we are multiplying the same bases with different exponents, we add the exponents together. So we do a plus b. So x to the a times x to the b equals x to the a plus b. A quick example of one like that would be x to the 5th times x squared is equal to x to the 7th, because we just do 5 plus 2 to get the 7. Now if we have x to the a divided by x to the b, we subtract. So it should be pretty easy to remember. Multiplying, you add. Dividing, you subtract. So if we had x to the 5th over x squared, we would subtract 5 minus 2 and get x cubed. And finally, we have x to the a raised to the b. That's equal to x to the a times x to the b. Excuse me, that's not what I meant to say. X to the a times b. So another example of that might be x squared cubed. That's really equal to x to the 6th because we do 2 times 3. The reason for that is cubed means times itself 3 times. So we get x squared times x squared times x squared, which if we add all those together using the first property, we get x to the 6th. Now let's actually apply those to some real problems. Let's say we have 2 to the 4th times 2 to the 8th over 2 to the 5th. Well, I'm going to do this in a couple steps. First, we know up top, since we're multiplying, we can add those exponents together. 4 plus 8 is 12. And then since we're dividing 2 to the 12th over 2 to the 5th, we can subtract the exponents and get 2 to the 7th, which if we need to plug this in, we can. 2 to the 7th, I believe, is 128. Okay, for this next example, to the negative first really means you're just flipping it over if it's a fraction. So 2 to the 5th to the negative first is going to be 5 halves, or 2.5. Either way, you can plug this in the calculator to confirm it. 2/5 raised to the negative 1 is 2.5, or 5 halves. Now in these next two, we can't really use the calculator. We've just got to use the properties. So for this first one, we're going to use the third property, the fact that if we have an exponent outside parentheses, then we can just apply it to those inside by multiplying. So there's 2 we need to do. It becomes y to the 10th, because we do 2 times 5, and z to the 15th, because we do 3 times 5. Now on the bottom, this last example, we can do something in the denominator first. We do 3 times 2, which gives us x to the 6th. And then when we divide, we subtract. So 3 minus 6. We can only do this with the x's because they are the same base. We can do nothing with the y because it's the only one. 3 minus 6 gives us negative 3. You're welcome to write your answer that way, or you can put that x back on the bottom since it's got a negative exponent as x cubed. So as far as my class is concerned, either one of those would be fine. One other thing that's important to know how to do is convert from exponents to radicals. So for example, if we have 125 raised to the 1/3, we need to know that that's the same thing as the cube root of 125. So raising something to the 1/3 power is the same thing as the cube root. You can do it in the calculator and confirm that. We can do the cube root, you go to math, number 4, of 125. That should be the same as doing 125 raised to the 1/3. Parentheses aren't necessary there, just so you know. It's fine to have them, you don't have to. But the answer is 5 either way. Okay, so for this next one, we need to distribute the 1/4 in first. So 1/4 comes in here. Notice there's no exponent there, but there's an understood 1 all the time, if there's not one written. So it's 81 to the 1/4. And then 1/4 times 4 gives me just 1, or to the first. So I can just write c. 4 times 1/4 is 1, so it just leaves me c. Now 81 to the 1/4 I can plug in that way, or I can rewrite it as the 4th root of 81 times c. I'll just do 81 raised to the 1/4. Gives me 3. So this is equal to 3c. Now for this last one, the 6th root of 9x cubed, I can rewrite the 6th root as an exponent of 1/6. Now that needs to get applied to both the 9 and the x. So we get 9 to the 1/6, and then 1/6 times 3 is 1/2. So x to the 1/2. You can plug the 9 to the 1/6 in the calculator to evaluate if you want to. Let's do a couple more examples with the radicals. Here we have the cube root of 64 s to the 9th t to the 15th. So we can rewrite this as 64 s to the 9th t to the 15th raised to the 1/3, because raising it to the 1/3 is the same as cube rooting it. So we can apply that in to each one of these. So it'd be 64 to the 1/3, and then 9 times 1/3 is 3, and 15 times 1/3 is 5. We can type in 64 to the 1/3. That gives us 4. So our final answer is 4s cubed t to the 5th. Now for this example, we have a square root. So whether we write it or not, there's an understood 2 right here, which may help you remember that a square root is the same thing as raising something to the 1/2. So this 1/2 gets applied to all 3 of these. Remember, we multiply these. So it'll be r to the 7/2. Sorry, my notebook is slowing down a little bit. We'll try that again. R to the 7/2, s to the 25/2, and t to the 3/2. The last type of problem you need to do is to be able to solve one with funny exponents. So for example, here we need to get the x to the 3/4 by itself first. So I'm going to subtract 5 from both sides. It's going to give me 729 is equal to x to the 3/4. Now the way to undo that exponent, or the way to get rid of it, is to raise both sides to the opposite, or the reciprocal power. So instead of 3/4, I raise both sides to the 4/3. Now on this side, we just do 3/4 times 4/3, which is equal to 1. So that's just going to equal to x. And we can do 729 raised to the 4/3 in our calculator to get the left side. And that's equal to 65/61. So when you need to get rid of an exponent, you raise it to the reciprocal of that exponent to make it go away.